Hey builders, today we are building a truly autonomous on-chain agent. For any app to operate on-chain, it needs two things: on-chain awareness to see what's happening, and on-chain action to respond. Historically, this was complex, requiring you to run nodes and manage private keys. Coinbase Developer Platform solves this by pairing their two flagship products. First, Data API. Data APIs provide on-chain awareness. We'll use the SQL API to monitor for new events in real time and the token balances API to check the current state of our wallets. Second, serverless V2. Serverless V2 provides on-chain action, so programmatic and secure transaction. Today, we'll combine all three to build an automated payments bot that monitors for new USDC transfers on base, periodically forwards a fee, and periodically checks the total balance of our treasury. This awareness to action loop is the core pattern for building sophisticated on-chain apps. Let's get building. So first, let's get the environment ready with a simple TypeScript project. So for this, you will need Node.js version 18% installed, a Coinbase Developer Platform account and project, and your CDP API key credentials and wallet secret. So I'm already on my terminal. So first, I'll create a new project folder and navigate to the folder. So NKDIR CDP payment bot and CDP payment bot. So I'll just hit enter. Once it's done, we'll initialize a new Node.js project in this. So I'll just enter npm init dash raw. So this will initialize a new package.json inside the folder. So once this is done, we'll set the package type to module and inside package.json so that we can use the new JS configuration and import statements. So I'll just set type to module. Once this is done, we'll install all of the required dependencies that we would need for this project. So I already have all of the packages here. So the most important package is Coinbase CDP SDK so that we can initialize CDP SDK and use serverless v2. Then we have .env for managing environment variables, Axios for managing request response through the CDP, SQL API, and VM for blockchain abilities. So I'll just hit enter. So this will take some time to install the dependencies. We just wait. Next, we'll install the dev dependencies, which should be TypeScript and node tags. So I already have them over here. So we'll install TypeScript and the node tags. So I'll just hit enter. After this, we'll initialize the TS configuration for our project. So for that, the command would be npx tsc-net. I'll hit enter. And this will initialize a new tsconfig.json in the folder. So we are almost done with the setup. Now, the only thing left is setting up the environment variables and starting with the project. So once you're done with the terminal setup, just open up the project in an ID. And here we'll set up the .env file first, which would handle all of the environment variables. And inside this, we'll also create another folder, SRC folder, which would have agent.ts. So in this agent.ts would be the main logic behind the payment processing bot. So now we can move to the .env file and set up our environment variables. So these are the environment variables that we would need for the project. First is the CDP API key ID and the API key secret, which you can get from the Coinbase Developer Platform portal. So in the Coinbase Developer Platform portal, just navigate to the API key section and you can create a new set of API keys and download them in your CC in a safe configuration as well. Next, you can get the wallet secret from the wallet section. So there is only single wallet secret for a whole project or account. So you can rotate the wallet secrets every now and then to keep the wallet secret safe in your Coinbase Developer Platform portal or dashboard. So get the wallet secret from the portal as well. And next is the client API key. This is the same config as the wallet secret in terms of rotation and only having a single client API key per project or per account. So you can get the CDP client API key directly from the CDP portal or dashboard. You can just copy it from there. And that's it with our environment variables. This should be enough for managing the CDP SDK and the SQL API along with token balances API as well. So now we are done with the project setup and now we can move on to implementing the main logic for agent.ts. Here we'll start by first initializing the CDP client and the constants. Before that, just a warning and a note that this demo will run on base mainnet as the CDP SQL API works only on base of now. So we'll be testing this live out on base mainnet and we'll be first testing out with small amount of USDC like 0.1 USDC and see like we send that 0.1 USDC to the designated receiver address. Was the payment processing successful by the bot? Was it able to calculate the 0.5% fees and send it to the treasury address? So we'll check that. So now let's start with the agent.ts step. So I already have the initial set of constants and the initializer or CDP client code Here, I'll just push it over here. So first, we have some imports from Coinbase CDP SDK, the CDP client import, which is the most important import for setting up the server wallets. Next, we have the Axios import for managing the API requests and responses that we'll send to the CDP SQL API. Next, we have .env for managing environment variables and encode function data from VM for encoding the ERC20 ABI function data. Once that is it, we load the environment variables using .env.config and then evaluate required environment variables. So we have 4 environment variables: API ID, secret, avoid secret, and client API key. So we make sure that all of these are present before we proceed running this agent.ts code. For that reason, we initialize a CDP client using new CDP client. So we don't need to attach any environment variables separately in this script. CDP SDK will automatically pick this up from the environment variables. So once it is done, we'll do a console log and the logs. And then we set up the official base mainnet USDC contract address. So you can get this from Basecamp. I got the USDC contract address from Basecamp. So this is the USDC contract address on base mainnet. Again, I am warning, this is a base mainnet demo. So make sure that you are testing with small amounts first if you are following along. After that, we have the CDP SQL API endpoint. So this is the API endpoint which we would use to process the requests and the responses. So this is api.cdp.coinbase.com/platform/v2/data/query/run. So this is the API endpoint. After that, we have the minimal ABI for the ERC20 transfer function, which we will be using to transfer the processing fee to the treasury wallet. So we'll be using the CDP SDK methods for that. So for that, this is a minimal ABI for ERC20 transfer function. And then we have the path definition for EVM account, which we will use for our functions in this event.ts code. So now, let's start off with the functions like provisioning an account and the SQL API functions as well. So first, we'll create the function for provisioning a new account. This would be a very simple function as we would directly calling the CDP SDK methods. So I have it over here. So this will provision a new EVM account managed by CDP or at least an existing one. So that's the beauty of using CDP SDK. You don't need to check that if a wallet is new or if a wallet is already existing. You had direct function in the CDP SDK to directly check all of those. You don't need to handle anything manually. So here we have the function provision account, which takes only one parameter, which is a name string, to distinguish between the addresses. And here we use a type definition that we used created before for EVM account. So this will return promise EVM account, so the address and the name. On the return, we have the try catch block where we have a console log first, and then we have the most important line for this function, which is a cost account await, and we'll use cdp.evm.get or create account to get an EVM account which is managed by CDP, or create a new EVM account if no EVM account exists under that name. So here we pass the name parameter and then we console log the account with the name and the address so that we can grab it from the console itself. After that, we return the account and then we have the catch block where we finish it off with the console error so that all of the errors are showing the logs and we can debug it. So now we are done with the provision account function. We'll move to the next function which handles the SQL queries. So let's move to the next function. I already have it over here. I'll replace it. So this is the function which would check for new payments. So this will query the CDP SQL API to find any new USDC transfer to our receiver address. And this will use the base.events table to query our transfer events. So we have the function over here, check for new payments with the receiver address and the large check timestamp. We would need this timestamp to make sure that we can differentiate between various timestamps and check every 10 seconds or every 20 seconds, or so that if the receiver address received any USDC payments. So first we have the most important block of this function, which is the SQL query itself. So here we query the base.events table for transfer events and we use parameter access pattern. So as you can see, we have used the parameter access pattern very clearly over here. So in this SQL query, use transaction hash with the parameter access pattern for from address, to address, and value. And we use parameters like block.timestamp, and we query the base.events table where the event signature would be the transfer event signature and the address would be USDC contract address, and the to address, which is where from the address that received the payment, would be our receiver address and with the block.timestamp. And we order this according to the ascending order and limit it to 100. So we only need the first 100 results of this. So that's the SQL query which would get all of the latest USDC transfers to a receiver address. Next, we have the try catch block which would execute the request to the API. So here we have the address first with authorization header, which would be CDP client API key. So this is an important part. Make sure that we send those authorized header, which would be the CDP client API key. Don't need to create any other JWT tokens or anything like that. You directly use the CDP client API key itself. Next, we have the content type, which would be application slash JSON. So here we have the response. So we will use the aggregates.post method with the CDP API URL, the SQL query, and the headers. And if we receive the response, we pass the response accordingly and return the response. And if nothing was returned, it will return an empty response. Next, we have the catch block where we accordingly pass the errors and show it in the console. So now that we are done with the check for new payments function, our final function would be related to token balances API, which checks the treasury balance every 60 seconds to see what's the status of the treasury address and what's the current token balances of the treasury addresses. So I already have the function over here. I just paste it. So this is the report treasury balance function, which uses the token balances API to check and report the treasury's USDC balance. So here the only parameter would be obviously the treasury EVM account. So in this EVM account, it would be the address and the name. So here we have the try catch block where we have the first part, which is the most important block for this function, where we use a cdp.evn.list token balances to get all of the token balances regarding this address. So here we have the parameter address where we set up the treasury address and the network base as this bot works on base. Next, we'll find the USDC balance in the response. So as list token balances gives all of the responses or all of the token balances response, you need to make sure that you properly pass them. So here we find the USDC balance in the response. So we'll use response.balances.find to check for the USDC contract address. And if there is a USDC contract address and if it contains a balance, we'll pass that balance properly and make sure that it shows up in the console. And the function is able to recognize how much USDC was transferred to the account. Once that is done, we have the else block, which would show if there is no USDC contract address, it means the treasury balance is still zero USDC. After that, we have the cash block where we make sure that if there are any errors, it shows up in the console. So once this is done, we have the final function, which would process the fee for the USDC transfer. So the next function would be the payment processing function. So this would make sure that the payments which are received, we process fee of 0.5% on them. So I already have the code. I'll just fetch it over here. So this uses the CDP SDK interval methods. So here we have the send fee transaction method, which sends the calculated platform fee from the receiver wallet to the treasury wallet. So we have the receiver account, treasury address, and fee amount as the parameters. So in the try catch block, we first convert to human readable amount for logging. So we first convert the forwarding fee or the forwarding USDC fee into human readable format so that we can see it in the logs. Once that is done, we create the transaction data for ERC20 transfer. So here we use encode function data, which we imported earlier from VM with the parameters ABI, function name, which would be transfer, and the arguments, which is treasury address and fee amount. Then we send the transaction using CDP SDK. So as you can see, it's very simple to send a transaction using the CDP SDK. You can directly use the method cdp.evn.send transaction method with the parameters address, which would be receiver account.address, network base, and the transaction parameters, which would be to USDC contract address, value would be 0 as no each value for token transfer, and the data which we already created before using encode function data. Once that is done, we console log and return the transaction hash. And if there are any errors, it will show us the error, and it will also differentiate between gas-related errors. And that's the final function for this agent code. Now we can finalize this agent.ts with the main function, which would trigger all of the functions properly according to the sequence. Third is the main function over here. So this is the main function which triggers all of the other functions to run the autonomous payment bot. First, we have some console logs, and then we have the try catch block, where the first step would be to provision the wallet that our agent will use. So first, we have the receiver account. So I have named it payment receiver bot. And then we have the treasury account, which would be platform treasury bot. After that, we have the critical warning, which I mentioned before. That is, this agent operates on days to minute with real funds. So, and some instructions to make sure that before we start, the receiver is funded with gas fees, and then we test with small amounts first, etc. After that, we initialize the timestamp for payment tracking, and this with the SQL format, as the timestamps that are initially generated are not according to the SQL format, and the SQL queries might fail. So we have accordingly filtered it to make sure that the SQL query do not fail with this timestamp format. Next, we have the SQL API connectivity block where we first test the SQL API connectivity with a simple query, which it is related to base events. Once it is done, we test this using access.post, which we have already discussed before, how we use a CDP API URL and the CDP client API key. And next is our loop one, where we check for new payments every 10 seconds. So this is our loop one, where we use a set interval function to set up a loop. So here we first check for new payments using receiver account or address and last check function. So if the payments length is greater than 0, or if there were any new payments, we will show the console log, which would say found this many payments. Then for each payment, we would make sure that the payment fee is processed properly. So here we calculate the payment fees, which would be 5% fees, and then send the fee transaction using the send fee transaction function that we created earlier with all of the parameters. And if the transaction was successful and the transaction hash is available, it will show up in the logs as well. And then we update the timestamp to avoid reprocessing. This is an important part of this bot to make sure that we don't reprocess any of the previous transactions. And we have some quiet logs as well to show periodically that this bot is watching for new USDC payments as well. Next would be the loop 2 to report treasury balance every 60 seconds using the token balances API. So here we have another set interval function for every 60 seconds where we do an initial balance report, and this will show us all of the balances. After that, we have the shutdown handler, and then we run the main function. And that's it. This finishes the processing bot agent.ts code. Now let's test this agent and see if our payment processing works properly or not. Now I wish to open up a terminal. And here, let's first run npm lending to build our state. And after that, we'll run npm extra. So let me just take this out. And yep, so the initial few console logs look correct. As you can see, the payment receive bot account was created. Payment platform treasury bot address is created as well. And some warnings with the receiver address and the treasury address. And now let's send some small amount to the receiver address and see if the payment processing works or not. So I just do it live. So I already have the address. So let me send some from my wallet. So I'll just send around 0.5 USDC and see if it works or not. So I'll just send 0.5 USDC. So I just sent 0.5 USDC. As you can see, it instantly processed the payment with the forwarding fee of 0.25 USDC, which is 0.5%. And the fee transaction was sent as well with a successfully processed fee for payment. So let me just follow this link. I'll just copy this and let's verify this as well once. So I'll do verify this. And as you can see, the transfer action was successful with 0.025 USDC sent to the address and to apply to a treasury address, and everything looks correct. So as we can see, with the combination of data APIs and the CDP server wallet v2, we were able to create a beautiful payment processing bot which automatically processes fee payments whenever the receiver wallet receives some USDC on base. Congratulations, you have built a sophisticated autonomous on-chain agent by combining Coinbase Developer Platform server wallet v2 and data APIs. This on-chain awareness to action is our architecture for countless applications from DeFi automation bots to on-chain gaming backends. And as the Coinbase Developer Platform API provides a unified API for a wide array of Ethereum networks, including Ethereum-based Polygon and more, the skills you have learned here are immediately transferable for building powerful multi-chain applications. It's your pen. Put this code, experiment with different SQL queries and on-chain actions, and build the next generation of automated on-chain services. For more details, check out the official Coinbase Developer Platform documentation at docs.cdp.coinbase.com and join the conversation in CDP Discord to connect with other builders and join the conversation with other teams and builders. Also, check out handlers.com for more advanced resources and tutorials on Web3. If you like this guide and tutorial by Handlers, please hit the like button, follow for more guides, and share it with other builders. Happy building!